Welcome. In this video series, we are covering how to build a bunch of different logic gates, and this video covers AND and NAND gate. You can find the playlist in the description. Okay, let's continue with NAND. You might wonder why we didn't start with AND, but rather with NAND. It's because in the AND situation, you have to use 3 transistors, so you need another transistor right here and connect the output here and invert the NAND to make it an AND. So you need a NOT gate here, which I would cover next. So because NAND is more simple, I'm covering NAND first. So our symbol is like this, and I didn't say this until now, but this bubble right here, it means it's inverted. So if you see a bubble, it means the 0 here turns to a 1, or a 1 here turns into a 0. So this bubble would represent an AND gate being inverted, turning it into a NAND. And this is the Boolean algebra representation of a NAND. So it's like a multiplication, and you're inverting it with this bar on top. And you can also make a NAND gate with a OR gate and inverting the inputs, but this is just for people that want to know more advanced stuff. Right now I'm not covering that. But by the end of the video, you can absolutely do such a thing because you will see the common pattern going on after covering the whole thing. Okay, so what is this NAND? Let's actually demonstrate that. So I have the circuit right here, the NPN version of the NAND. And as you can see, when both inputs are 0 volt, so we have now 2 inputs, we are getting 5 volts. And if either one of them goes to 1, we are still reading 5 volts. So a 0 volt, 5 volt, or a 5 volt, 0 volt, still 5 volt. But if both of them are 5 volts, both inputs, we read 0 volts on the output, which is right here. And for the people curious about the transistor I used the BC337. All of the NPNs in this video are BC337, and all of the PNPs in this video are 2N2907. Okay, so what's going on in this circuit then? When you give 0 volt and 0 volt as an input, the NPN is off, so it doesn't allow any current flow, and so this 0 volt here doesn't get shorted to this location. If either of them is a 1, so you give a 5 volt here, and the transistor turns on, the other one is not on, so you get a 0 volt short here, but it doesn't get shorted to the top. So the output is still 5 volts. And vice versa, if it's 5 volt here and 0 volt here, this output is now shorted like here, but this is not open yet. So it doesn't allow any current flow, and it doesn't get shorted. But when you give 5 volt to both of them, it allows the current flow, and the 0 volt essentially gets shorted here, and we see output as 0 volt. Okay, what about the PNP version? As you can see, we see like a major shape difference. Now instead of like in the NPN case being in series, now the transistors are in parallel. That's interesting. So let's actually do that in the circuit. So I'm giving 5 volts to my circuit, and let's read this exact location. It's not quite visible, but this is our load resistor, and we are reading right on there from the schematic as shown in the schematic. So when both inputs are 0 volts, we are reading 5 volt. One of them is 5 volt, we are still reading 5 volts, and vice versa. But if both of them are 1, you're reading 0 volts. So it's the NAND behavior. And you also notice that if I even remove both of them, it stays at 0 volt. It's because of the pull-up resistor that we have in there. So by default, if nothing is connected, it's pulling it to 5 volts. And in the previous video, I also explained why that's important. It's because we don't want a floating base that might partially turn on the transistors with the parasitic capacitance of the base. So what's going on here? It's quite simple. You give 0 volts here, and the PNP, this PNP turns on. We are shorting 5 volts up here, down there, output reads 5 volt. And it's same case for the other one. If you give 0 volt to this input, then it's also the same situation. It's shorted from there. If you turn both of them on, it's the same situation. You give 0 volt to both sides. It's, yeah, just shorting. But if you give 5 volts, nothing turns on. This transistor is off. This transistor is off. There is no current flow. So the 5 volt here doesn't get shorted down there, and you're reading 0 volts. Okay, hopefully that makes sense. So let's look at the AND case. So to make an AND, we have to connect an NOT gate to the output right here to invert the logic. And also here you can see the bubble here is gone, so it's a normal AND gate. And also the advanced version, here you can see a bubble added right there to invert it. And this is the Boolean algebra representation of both of them. So let's actually do that in the circuit. Okay, so I connected power to the NOT gate we built, and here's our NAND NPN version. We are going to connect our input of the NOT gate from here to our output of the NAND gate, which is right here. And then we are going to read from the output of the NOT gate, which is right here, and then give power to the circuit. So when both inputs are 1, we are reading 5 volts. If either one of them goes 0 volt, if we are reading 0 volts, it's a typical AND gate. And also you can see it doesn't matter if it's connected or not because of the pull down resistor. And the same situation for here. If both 0 or either of them are 0, we are just going to read 0 volts. And if only and only if both of them are 1, we are going to read 5 volts. Okay, this is how that one works. And now let's look at the PNP version. It's the same thing. We just connect the NOT gate to our output of the PNP version. So let's do that. You notice that I'm changing the location of the power. It's because I'm not sure if this is a universal thing, but my breadboard's power lines are separated from here. So this half is not connected to this half power wise. So I have to just flip this. And this is our PNP version. This is our PNP version of NOT gate. And let's read from the PNP NOT gate output. And let's give this input to our PNP output, which is right here. Okay, let's give power to the circuit, and we have pull-up resistors. So when both of them are 1, so it doesn't matter if I connect them or not right now, we get 5 volts, so it's a 1. If either of them are 0, it's gone. Either of them. Both of them, same thing. We get 0 volts as the output. I know some people will be curious and ask, can we connect a PNP NAND to an NPN NOT? Okay, let's try that and actually see if it works. So let's connect the input of the NOT gate to our output of the PNP. And let's read the output of our NOT gate. And yes, it does work. Remember I said look at the voltage and not the light bulbs, not the current, not anything. Yeah, it's because if you work with the voltage and not say light bulb is on and off, you will get less confused. These components don't care about light bulb, they care about the voltage. So when we give 5 volts from the output here, it turns this one on, we are shorting from here. And right now we do that actually because we are giving 0 to the PNPs and turn them on. So it doesn't matter which one of them is 0 because they're in parallel configuration. Either one of them is 0 volts, it's going to turn either one of the PNP transistors on, and we're going to get 0 volts on the NOT gate output. If both of them are 1, which means both of the transistors are off, we are giving 0 volts here, and that 0 volts gets here, and this NPN is off, and so we receive 5 volts going from this resistor to here. So yes, you are more than welcome to use PNPs and NPNs together, do whatever logic you want, but there's probably infinitely many different ways you can just do stuff, and I cannot cover all of them. So these are just general stuff, and I'm not gonna cross stuff together. So it's I'm gonna use PNPs with PNPs and NPNs with NPNs just to not confuse anyone. Thank you for watching. In the next video, we are gonna cover OR and NOR gate. And you can find the playlist in the description. Ne oldu? Oha ama.